Okay. So, let's draw a few more. This is a triangular wedge. Another triangular wedge is kept like this, and a third triangular wedge is also kept symmetrically. There's a force F. Symmetrically, there's another force on the other side F, and the whole system is kept stationary like this on surface. Now draw the FBD for the wedge at the center. Draw FBD for each wedges. Draw FBD for all the wedge. The FBD for the center, let's start drawing it. One of the forces that you should be quick in drawing is mg, acting downward, always. Another contact is here. So there is one normal reaction from the surface upward. You can draw it like this, N. There is third contact here, and these two are pressing each other. So there will be some normal reaction at this end, and that normal reaction will always be perpendicular to the surface. So there is another normal reaction, but you don't have to draw it upward because it is pressing. This center wedge is pressed to the left by the wedge on the right. So the normal reaction would be on this side, but it would be always perpendicular to the surface. So this is another normal reaction, but it is acting always perpendicular to the surface. And similarly from this side, you'll have a normal reaction like this, but again perpendicular to the surface. The same FBD, if everything is symmetrical, you can show the forces like this as well. All the forces, you can shift this vector because this vector is crossing through the center. So you can shift this vector and bring it here and make the FBD look like this. But you can do this only if the vector is actually passing through the center. Okay, so both are correct. And for the wedge on the side, you can again very easily make the FBD showing all the forces. One of the forces is shown, this is F. From the center, you will have mg. From here, this is a contact. This is a point contact on the surface, but nevertheless, this is a contact. So there will be some normal reaction from this point contact as well. Suppose there's one wedge kept just like this on the floor. There is a point contact here, but still there will be normal reaction at the point contact as well. So there will be some normal reaction at this point contact for the side wedge, and that would be upward. And there is a surface of contact here. The two are being pressed. The force is pressing this wedge to its right. So this wedge will be pushing it to its left. So at this contact, this wedge is going to have a force perpendicular to the surface to its left hand side. These are action-reaction pairs. So if I've written as N dash, I should also write this as N dash. Okay, so this is how you draw the FBD. Okay, let's try one more and then we'll start with writing equations and we'll move ahead. This is a larger sphere, and with the help of this, we have stationed a smaller sphere. Suppose this is 3r and this is r, and this distance, suppose I give you as 4.5r. Then draw the FBD for this smaller sphere. All the forces with proper angles. Okay, let's isolate this smaller sphere. Let's look at all the forces that will act on this. One of the obvious force is mg, acting downward, and this there's a contact between the sphere and the wall, although not drawn neatly, but there's a point contact between the sphere and the wall. Will be, if it's a sphere and the wall is plane, there will be a point contact between the sphere and the wall, and that there will be some normal reaction. Normal reaction will be perpendicular to the wall. This is how the normal reaction will be acting on the sphere, because sphere will tend to come down and press this sphere and the wall on both sides in order to come down. So sphere is pressing the wall on this side, so the wall will be applying some normal reaction on the other side. So this is how the normal reaction will be applied on the sphere. There's a third contact at this point. Again, at this point there will be some normal reaction, and this time again this smaller sphere will be trying to push the larger sphere in order to come downward on the left hand side. So the larger sphere will be applying some force on the right hand side, and the normal reaction would be acting perpendicular to the surface. And we have seen before, when there are two spheres like this, we draw the tangent, that becomes the surface, and the normal reaction will be perpendicular to this tangent, like this. And the perpendicular on the tangent passes through the radius. We have learned this long back in school. So this will be the normal reaction from the larger sphere. Now I told you to draw it with proper angles. Now with proper angles you can draw it like this is mg, this normal reaction is from the wall, nw, and this normal reaction is from the sphere, ns. But this is 90-degree fine, you have to find this angle, and that's why I gave you dimension, and finding this angle is as easy as candy from basic geometry. This is 4r, right? This is r, and I've given you this as 4.5r.